Good morning students, myself Venkatesh. Now in this class we are going to study about structure of page table and segmentation. Okay, in previous class we have studied about what are the various partition allocation policies like best fit, worst fit and first fit, and what is meant by fragmentation. So what is internal fragmentation, what is external fragmentation, what is the solution for in fragmentation, and what is meant by paging. In this paging we are going to talk about pages and frames, what is the hardware architecture of paging, and at the same time what is TLB hit and TLB miss. Okay, that is in the concept of paging with TLB, that is the translation Lucas said before, how we are going to provide the protection in paging concept. So in this class purely we are going to talk about the what are the structure of the page tables. Okay, the structure of the page tables we are going to divide into three categories, that is hierarchical paging, inverted page table and hashed page table. Okay, this is the structure of a two level page table scheme. We have outer page table, in between we have page table, we have outer page table, here we have memory. Okay, so in most of the modern computer system support a large logical address space, that is 232 to 264. In such an environment the page table itself become exclusively large. For example, consider a system with a 32-bit logical address space. If the page number in such a system is 4 KB, that is 212, then a page table may consist of up to 1 million entries. Assuming that each entry consists of 4 bytes, each process may need up to 4 megabytes of physical address space for the page table alone. Okay, here clearly we could not want to allocate the page table continuously in main memory. One simple solution is of this problem is to divide the page table into smaller pieces. Okay, we can accomplish this division in several ways. Okay, so this is the two level page table scheme. Okay, so next one is a hashed page table. See, what is the concept of hashed page table? Okay, here the in this hashed page table, the virtual page numbers is hashed into the page table. Okay, so in this one the major thing is the virtual page number is hashed into page table. Okay, so this page table consists a chain of elements hashing to the same location. Each element contain virtual page number, the value of the mapped page frame, and the third one is a pointer to the next element. Okay, so this is the representation of the hash page table. Virtual page numbers are compared in this chain searching for a match. If a match found, then the corresponding physical frame is extracted. Okay, so this is the representation of the hashed page table. So next one is inverted page table. See, what is meant by inverted page table? Okay, so here inverted page table, in this inverted page table has one entry for each real page or frame of memory. Each entry consists of the virtual address of the page stored in that real memory location, which information about the process that owns the page. Okay, thus only one page table is in the system and it has only one entry for each page of physical memory. Okay, here we have page table, we have PID and P. Okay, here PID, P and D, D is after, P is page number, here PID and page number. Okay, here offset. Okay, so in this way we are going to performing the inverted page table. So next concept is segmentation. See, what is meant by segmentation? See, segmentation simply what is meant by segments. Okay, so segments are, we can say a program is a collection of segments. Okay, a program is a collection of segments. Okay, and then what is a segment? A segment is a logical unit such as main program or procedure, function, method, object, local variables, global variables, or we can say common block, stack, symbol table, arrays. Okay, so this is the logical address we have in this one: subroutine, stack, symbol table, square root, main function. Okay, an important aspect of memory management that become unavoidable with paging is the separation of user view of memory from the actual physical memory. Okay, as we have already seen, the user view of memory is not the same as the actual physical memory. The user view is mapped onto physical memory. This mapping allows differentiation between logical memory and physical memory. Okay, the memory management scheme that supports user view of memory. Okay, generally in operating system, segmentation is a memory management technique in which the memory is divided into the variable size pods. Okay, each pod known as segment, which can allocate to a process. Okay, the details about each segment are stored in a table called as segment table. Segment table is stored in one of the segments. Okay, segment table contains mainly two information about segments, that is base and limit. Okay, so what is meant by base, what is meant by limit? Okay, here base is the base address of the segment, whereas limit is the length of the segment. Okay, limit is the length of the segment. Okay, so why segmentation is required, why we are using this segmentation? Okay, so why is until now we were using paging as our main memory management technique, but paging is more close to operating system rather than the user. Okay, it divides all the processes into the form of pages, regardless of the fact that a process can have relative parts of function which needs to be loaded in the same page. Okay, operating system does not does not care about the user view of the process. Okay, it may divide the same function into different pages, and those pages may or may not be loaded at the same time into the memory. Okay, it decreases automatically efficiency of the system. Okay, it decreases efficiency of the system. So it is better to have segmentation which divides the process into the segment. Each segment contains same type of function, such as main function can be included in one segment and the library functions can be included in other segment. Okay, here translation of logical address into physical address by table. Okay, here CPU generates a logical address which contain two parts, that is segment number and the second one is offset. Okay, segment number and offset. Okay, here segment table. Okay, in this one base and limit. Here we have physical address. Initially we have operating system, segment 1, here's different segments, segment 1, segment 2, segment 3, segment 4 and segment table. Okay, here CPU generated address is logical address. Okay, the segment number is mapped to the segment table. The limit of the respective segment is compared with the offset. Okay, we are going to compare with the limit, we are going to compare the limit with offset. Here we are performing the comparison. If the offset is less than the limit, then the address is valid, otherwise it throws an error as the address is invalid. Okay, if it is yes, address is valid. If it is no, we can say it is a trap or invalid. If it is in the case of valid address, okay, if it is in the case of yes, okay, the base address of the segment, okay, is added here plus. Okay, we are going to add the base address of the segment to the offset to get the physical address of actual word in the memory. Okay, here the thing is, in this here in previous case we are using page map table, here we are using segment table. Okay, same comparison, we are going to compare the limit with offset. Okay, if it is yes, then we are going to add the base value. Here if you see base, here plus, for plus we are going to add base. Okay, add base value in order to get the corresponding page in the physical address. Okay, in the main memory. Okay, in the case of valid address, the base address of the segment is added to the offset to get the physical address of actual word in the main memory. Okay, so this is the translation of logical address into physical address by segment table. Okay, so next to, what are the various advantages? What are the various advantages of segmentation? Okay, advantages of segmentation and disadvantages of segmentation. If you take the advantages of segmentation, there is whereas comes to advantages, there is no internal fragmentation in segmentation. Okay, so here we are not losing any memory, we are not losing any memory in the segmentation. Okay, next one is average segment size is larger than the actual page size. So this is also one of the advantage. So next one is, we can say it is less overhead. Okay, segmentation is one of the we can say it is one of the less overhead. Okay, next one is, it is easier to reallocate segments than entire address space. This is also one of the advantage. Whereas next one more advantage is, the segment table is of lesser size as compared to the page table in paging. Okay, so here size of the segment table when compared to page table. Okay, the segment table is of size less size compared to the page table in paging concept. Okay, so all these are the advantages of segmentation concept. Okay, so what are the disadvantages? What are the various disadvantages of segmentation? Okay, it can have external fragmentation. Okay, in this one we are going to a problem of achieve the problem of external fragmentation. At the same time, one more drawback is, it is difficult to allocate continuous memory to variable sized partitions. Okay, for variable sized partitions, it is difficult to allocate continuous memory. Okay, we can't get the continuous memory allocation for the variable sized partitions. And next one is, it is one of the costly memory management algorithm. Okay, it is one of the costliest memory management technique. Okay, so these are all are the different disadvantages of the segmentation. Okay, so this is about segmentation. Okay, so in this class we have studied about purely different types of structure of tables. Okay, as well as at the same time what is segmentation. Okay, so how we are going to map the logical address with physical address. Okay, so this is regarding segmentation. Okay, so these are the different types of structure tables. Okay, so this is the memory protection in paging concept. Okay, this is the concept of TLB hit and TLB miss. Okay, this is the, so here this is the hardware architecture of paging is different, and the architecture of paging with TLB is different. Okay, so here this is one of the major important, paging is the one of the important concept in the examination point of view. Okay, so if you want to write the hardware architecture of paging, so you should write like this is you should write this architecture only. Okay, that is CPU, here page number, here offset, again frame, offset, we have page map table. We should represent this architecture, whereas paging with TLB. Okay, in this case you should represent the architecture with TLB. Okay, we should represent the architecture with TLB. Okay, so this is the paging concept. Okay, so next we have studied about fragmentation. Okay, fragmentation means internal fragmentation as well as external fragmentation. So here external fragmentation means, so we have process P4. So process P4, P1, P2, P3, P4. Already P1, P2, P2, P3 is stored in the different partitioning locations. That is P1 over, P2 over, P3 over. Here P4. Okay. So P4 we can't store. Why? Because 80 and 100 it is not in continuous. Okay. It is external fragmentation. Okay. Then these are the allocation policies. Okay, first fit, best fit, worst fit. Okay, we have seen this example, like now how we are going to allocate the different processes in different partitions, memory partitions. Okay, here we have 5 partitions. Okay, 5 partitions with 4 processes, 5 partitions with 4 processes. How we are going to keep all these 4 processes with 5 partitions. Okay, all these processes are in order. Okay, whereas partitions are also order. We have 100, 500, 200, 300, 600. So partitions are P1, P2, P3, P4. P1 of size 212, P2 of size 417, P3 of size 112, P4 of size 426. Okay, so how we are going to store in this first fit, best fit, worst fit. Okay, all those things we have studied till now. Okay, up to now we have covered the concept of memory management in third unit. Okay, so in memory management concept, initially we have studied about memory management. So what are the functions of memory management and what are the goals of memory management, and at the same time what is fence address. So how we are going to differentiate the fence address, and next one is what is memory management unit, and at the same time what is the concept of swapping. In the concept of swapping, what is the rolled out and roll in, that is we can say swap out and swap in. And next one is memory management techniques, that is continuous and non-continuous. And next one is whereas in continuous we have studied about partitioning methods. We have 2 partitions majorly. We have MFT and MUT. That is MFT means multi-programming with fixed task, multi-programming with variable task. Okay, and next one is in this partitioning policies, different policies like first, best, worst. Okay, after completion of partitioning policies, next we came for fragmentation. In this fragmentation, majorly internal fragmentation and external fragmentation. And next, after completion of fragmentation, we have studied about paging concept. So in this paging also, what is the architecture of paging, what is the concept of paging, and paging with TLB, that is a translation look aside buffer. And this one, next one is memory protection in paging. And next concept is in this class, especially we have covered the structure of page table. At the same time, in this structure of page table, we have majorly 3 types, that is hierarchical paging, hashed page table, and next one is inverted page table, and finally segmentation. Okay, so what is meant by segmentation? How we are going to map the logical address with the physical address by using the segmentation table. In paging we have page map table, whereas segmentation we have segment table. How we are going to map the logical address with physical address. Okay, then what are the advantages of segmentation, then what are the various disadvantages of page table. Okay, all those things we have completed till now. Up to this we have covered the concept of memory management in unit 3. Okay.